Estimating non-perfect square roots is a pretty fun topic for my 8th graders, or maybe you're learning it in 7th or even in high school, or maybe you learned it a long time ago and you're coming back for a nice refresher. The biggest challenge that students always face is if they don't know their perfect squares well enough, this topic can be a little rough at first. So I'm going to pop up the perfect squares on the screen for you to take a look at. These perfect squares are the bread and butter to success when you're estimating non-perfect square roots, especially without the use of a calculator. So for example, if you take a look at the square root of 121, well, what number can you multiply by itself to give you 121 back? Well, the only answer that's right is 11. And these perfect squares can help you narrow down the answer to non-perfect square roots. For example, the square root of 73. Well, what number can you multiply by itself to give you 73 back without using a calculator? It's going to take you a long time to figure out that answer, which is why we're going to estimate it. So let's get into the video. In number 1, we have the non-perfect square root of 58. It's almost impossible to figure out, well, what number can you multiply by itself to give you 58 back, especially without the use of a calculator, which is where our perfect squares come into play. So the square root of 58 falls between the two perfect squares of 49 and 64. So we're going to place those on each end of the number line. So we have the square root of 49, which gives us 7 back because 7 multiplied by itself gives you 49. And then on the other end, we have the perfect square of 64, which gives 8 back. So we know when we're estimating the square root of 58, it has to be between 7 and 8. So it's going to start with 7 point something. So I'm just going to jot that down here, right? But we want to get a little bit more precise than that, right? I always tell my 8th grade students, if we can get to the nearest tenths place, then I think we did a really nice job estimating. So the next step is then to find the midpoint, or what square root is perfectly between 49 and 64, which is right around 7.5. And that's going to be 56 and a half. So we have 7.5 right in the middle. And then we have the square root of 56 and a half. This way we can narrow down now, is the square root of 58 on the lower half of the number line, so between 7 and 7.5, or is it actually between 7.5 and 8? And in this case, the square root of 58 is going to be on the higher end of the number line. It's above 7.5 and below 8. So the square root of 58 is 1.5 numbers away from 56.5. So it is relatively close to 7.5, whereas it's 6 numbers away from 8. So when we go ahead and take our estimate here in a second, we want to make sure that we're closer to the middle than we are 8, just because it's 1.5 numbers away versus 6 numbers away. So my estimate for this is going to be 7 and 6/10, right? It's not going to be exactly 7.5 because it's still 1.5 numbers away, but it's definitely closer to the middle for sure than on the other end at 8. Right, now let's go ahead and take a look at number 2. This time around, it's between the two perfect squares of 121, which gives 11 back, and the square root of 144, which is going to give 12 back. So we know our estimate is definitely going to be 11 point something, and now we want to go ahead and find our midpoint at 11.5. And this time around, it's going to be the square root of 132.5, which is right smack in the middle of 121 and 144. And we notice 137 once again falls on the upper half of our number line. So 137 is 4.5 numbers away from 132.5, and it's 7 numbers away from 144. So once again, it's leaning more so towards the middle than it is 12. So we want to make sure that we're closer to 11.5 than we are 12. However, it's not incredibly close like the 1.5 was in the previous one. So my estimate this time around is going to be 11.7. Again, still leaning towards the middle, right? But still a little bit further away. We just don't want it to be closer to 12 than it is 11.5. So my estimate's going to be 11.7. For number 3, we have the square root of 15. That is between the two perfect squares of 9, which is going to give us 3 back, and the square root of 16, which is going to give 4 back. And then once again, let's go ahead and find our midpoint at 3.5, which is going to be at 12.5. The square root of 15 falls on the upper half of our number line again, and notice how close 15 is to 16, right? It's 1 number away, right? And it's further away from the middle because what? It's 2.5 away. So if we wanted to estimate 15, well, it's really close to 16. It's only 1 number away. So I would say a good estimate for this would be 3.9 because it is relatively close to being 4. Okay, now let's go ahead and take a look at the next one. We have the non-perfect square root of 41. Well, that's between the two perfect squares of 36, which is going to give us 6 back, and then the square root of 49, which is going to give us 7 back, right? And then once again, we want to go ahead and find the midpoint, which is at 6.5. And then the number that is perfectly between 36 and 49 is going to be 42.5. And this time around, 41 is on the lower half of our number line. So 41 is 5 numbers away from 36, and it's only 1.5 numbers away from 42.5. So again, it's going to be leaning more so towards the middle versus being closer to 6. So a good estimate for this would probably be 6.4, because again, much closer to 6.5 than it is 6. So let's go ahead and estimate that at 6 4/10. And then finally, the very last one, it is between the two perfect squares of 100, which is 10, and the square root of 121, which is 11. And then let's go ahead and find 10.5, which is going to be 110.5. Now, since we're looking at the non-perfect square root of 110, and we have 110.5 right in the middle, it's almost literally the same exact number. So I'm going to estimate it right in the middle at 10 5/10, right, for our fifth one. Now, before we go, I do have 5 practice problems for you to try out on your own. So let's go ahead and dive right into them. Ladies and gentlemen, it's the moment you've all been waiting for. It's time for the practice session. I encourage you to pause the video and try estimating all 5 of these non-perfect square roots on your own. Feel free to draw out 5 number lines, figure out what 2 perfect squares each one of these fall between, and see if you can get to the nearest 10th. So pause the video here, try out all 5, and when you think you're ready to go, press play on the video and see if you got a perfect score on it. So I'm assuming at this point you have tried out all 5 questions and now you're ready to go over the answers. Can you go 5 for 5? Well, it's a moment of truth. Let's go ahead and find out. The square root of 7 falls between the 2 perfect squares of 4 and 9. The square root of 4 is 2, and the square root of 9 is 3. Now, we're going to go ahead and find the midpoint here like we did in the other ones at 2.5, and that's going to be the square root of 6.5. Now, 7 falls between 6.5 and 9, and it's very close to 6.5. It's legitimately 0.5 away. So I am definitely going to make my estimate very close to this at 2.6 or 2 6/10. Right, so hopefully you're 1 for 1. I'm also going to pop up on the screen what the exact answer is to this square root. That way you can see how close are we actually just by estimating. Now let's go ahead and jump over to number 2. It falls between the 2 perfect squares of 100 and 121. Now the square root of 100 is 10, and the square root of 121 is 11. And then once again, let's go ahead and find the midpoint for 10.5, which is going to be 110.5. Now, 109 falls on the lower half of our number line, so it's going to be between 10 and 10.5. And once again, it's very close to the middle. It's only 1.5 numbers away versus being 9 numbers away from 100. So I am going to estimate this at 10 4/10 for number 2. Right now for number 3, it falls between the 2 perfect squares of 16, which is 4, and the perfect square of 25, which is 5, and then once again the midpoint, which is going to be 4.5, and that's going to be the square root of 20.5. Now 22 is going to be on the upper half this time because it's between 20.5 and 25. It is 1.5 numbers away from the middle, and it's 3 numbers away from 5. So it's still a little distance away from 4.5, but it's definitely closer to the middle than it is to 5. So I would estimate this one at 4 7/10 for number 3. So hopefully you are 3 for 3 right now, and we're down to the last 2. We have the square root of 67. So that is between the 2 perfect squares of 64, which gives 8 back, and the perfect square of 81, which gives 9 back. And now let's go ahead and find our midpoint, which is 8.5. That's going to be the square root of 72.5. 0.5, and then 67 falls on the lower half, so it's going to be between 8 and 8.5. 67 is only 3 numbers away from 64 versus being 5.5 away from 72.5. So it's leaning closer to 8 this time than it is 8.5. So I'm going to estimate this at about 8.2, right? It's still 3 numbers away from 8, but still leaning closer to 8 than it is 8.5. So our estimate for this should be 8 and 2/10. And then our very last one, the non-perfect square root of 137 is between the perfect squares of 121, which is 11, and 144, which is going to be 12. And then we want to find what 11.5 is, which is going to be 132.5. And then 137 again falls on the upper half of our number line, so it's going to be between 11.5 and 12. 137 is closer to 132.5 versus 144, right? It's still a little bit a ways from 11.5, so I want to estimate this at 11.7. Again, leaning more so towards the middle than 12, okay, because it's closer to 132.5 than it is 144. So our estimate for this is going to be 11 and 7/10. Right? Hopefully you went 5 for 5 in the practice session, and if you did a very, very nice job on estimating non-perfect square roots. As long as you know your perfect squares, you can be very, very successful at this topic. So if this video helped you out, again, please leave a like on the video, letting me know that I did a great job. Comment any other topics that you want to see, and make sure to subscribe. Turn on the bell for post notifications when I post the next math video. And once again, we'll see you in the next one with some more mathematics.